Hello guys, welcome to i-tutor Academy. In today's session, we will start with the Unit 14, subsection 4 of MMBC005, that is rank correlation. Quite often data is available in the form of some ranking for different variable. It is common to resort to ranking on preferential basis in areas such as food testing, competitive events and attitudinal surveys. The primary purpose of computing a correlation coefficient in such a situation is to determine the extent to which the two sets of ranking are in agreement. The coefficient that is determined from this rank is known as Spearman's rank correlation coefficient, that is R. This is given by the following formula. Here n is the number of pairs of observations and di is the difference in ranks for the first ith observation set. And the table 4, that is determination of Spearman's rank correlation, is here. And we can thus say that there is high degree of correlation between the performance in mathematics and physics. Okay, so that is an example, and equation also here you just refer, and referring to the table of the t distribution for n minus 2 is equal to 8 degree of freedom. The critical value for t at a 5% level of significance is 2.306. Since the calculated value of t is higher than the table value, we reject the null hypothesis, concluding that the performances in mathematics and physics are closely associated. And activity D is here, you just try to do it. And practical application of correlation. The primary purpose of correlation is to establish an association between any two random variables. The presence of association does not imply causation, but the existence of causation certainly implies association. Statistical evidence can only establish the presence or absence of association between variables. Whether causation exists or not depends merely on reasoning. For example, there is reason to believe that higher income causes higher expenditure on superior quality cloth. However, one must be on the guard against a spurious or consensus correlation that may be observed between totally unrelated variable purely by chance. And correlation analysis is used as a starting point for selecting useful independent variable for regression analysis. For instance, a construction company could identify factors like population, construction employment, building permits issued last year, which it feels would affect its sales for the current year. And these and other factors that may be identified could be checked for mutual correlation by computing the correlation coefficient of each pair of variables from the given historical data. This kind of analysis is easily done by using an appropriate routine on a computer. Only variable having a high correlation with the yearly sales could be singled out for inclusion in a regression model. Correlation is also used in factor analysis, wherein attempts are made to resolve a large set of measures and variable in terms of relatively few new categories known as factors. The result could be useful in the following three ways: to reveal the underlying or latent factor that determines the relationship between the observed data, to make evident relationship between data that had been obscured before such analysis, and to provide a classification scheme when data scored on various rating scales have to be grouped together. And autocorrelation and time series analysis. The concept of autocorrelation is similar to that of correlation but applies to values of the same variable at different time lags. Here is one figure, that is example of same variable with the different time lags. Okay, and it can be used to construct another variable x1 whose only difference from the first is that its value are lagging by one time period. And then x and x1 can be treated as two variable and their correlation found. And so here is the table, so you just go through it, and equation also here and explanation also here. Okay, so you just go through it. In case any doubt, you can contact us. And summary of this unit is the concept of correlation or the association between two variables have been discussed. A scatter plot of the variable may suggest that the two variables are related, but the value of the percent correlation coefficient quantifies this association. The correlation coefficient R may assume value between -1 and 1. The significant indicates whether the association is direct positive or inverse, that is negative. A numerical value of R equal to unity indicates perfect association, while a value of 0 indicate no association. Test for significance of the correlation coefficient have been described. Spearman's rank correlation for data with rank is outlined. Application of correlation in identifying relevant variable for regression, factor analysis, and in forecasting using time series have been highlighted. Finally, the concept of autocorrelation is defined and illustrated for use in time series analysis. So this is about today's session, and self-assessment questions also further is here. You just go through it one by one and try to do it. It will help you for your term and examination, and parallelly you just do your assignment also, and in between any doubts you can contact us. For more IGNOU MBA videos, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents IGNOU MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.